Yo, welcome back. This is me, Totality Audio. Today, if you're looking up what I'm doing here, is physics revisions, short revision of physics. I've been like studying physics a bit long time, as you can see. I've been doing this. You know what? Let's tilt the camera.
आखिर छक्का मारकर भी क्यों पेविलियन लौटा बांग्लादेश का ये खिलाड़ी?
Okay.
चहल का वो ब्रेन फेड मोमेंट जिसने धोनी को फ्यूरियस कर दिया, और डब्ल्यूटीसी चैंपियन टेम्बा बवूमा ने ऐसा क्या किया कि कोई भी अपनी हंसी नहीं रोक पाया। आज आपको दिखाते हैं क्रिकेट के ऐसे लो आईक्यू मोमेंट्स जहां खिलाड़ी लिटरली अपना दिमाग घर छोड़कर आए थे। Surely, what is happening here? You need to pull yourself up. This is a comedy of errors. सबसे पहले बात करते हैं हमारे यूजी चहल की। जो वैसे तो बल्लेबाजों को फिरकी में फंसाने के लिए जाने जाते हैं, लेकिन इस मौके पर खुद ही फिरकी खा गए। मौका था भारत और इंग्लैंड के एक टी20 मैच का, जहां चहल की बॉल पर जो रूट कवर्स पर एक शॉट मारते हैं, जहां मौजूद विराट कोहली जबरदस्त फील्डिंग करके बॉल को रोक लेते हैं। इंग्लिश प्लेयर्स ने ये एक्सपेक्ट नहीं किया था, और इसीलिए नॉन स्ट्राइकर्स एंड पर रनआउट का क्लियर मौका बन रहा था। विराट की थ्रो भी सीधे चहल के हाथों में आती है, पर चहल नॉन स्ट्राइकर्स एंड पर थ्रो
Yo,
करने
this
के
is
बजाय
actually going
विकेट
crazy,
कीपर
man.
धोनी
Oh
की ओर
my
बॉल
god.
फेंक देते हैं,
Very
जहां का
chaotic.
बैट्समैन ऑलरेडी क्रीज के अंदर था। चहल की इस गलती से इंग्लिश प्लेयर रनआउट होने से बच जाता है, और धोनी चहल पर बहुत ज्यादा भड़कते हैं।
This
असल
is
में
gonna be
चहल
super
अंपायर
chaotic,
और इंग्लिश
isn't it?
प्लेयर्स की यूनिफॉर्म के सेम
Not
कलर के
sure.
कारण कंफ्यूज हुए थे, लेकिन थोड़ा भी दिमाग लगाते तो इंटरनेट पर मीम मटेरियल बनने से बच जाते। Yes, well, it was a combat, Jason Boy. वैसे असली मीम मटेरियल तो यहाँ केन रिचर्डसन बन जाते हैं, जिनके पास नॉन स्ट्राइकर्स एंड पर बल्लेबाज को आउट करने का पूरा मौका होता है और समय भी होता है, लेकिन इसके बावजूद वो जल्दबाजी में अंडर आर्म थ्रो को भी मिस कर देते हैं। और इस लेवल की
What do you
स्टुपिडिटी
guys think? The
क्रिकेट
first
में
half
सिर्फ
should be
केन रिचर्डसन ने
minus
नहीं
G
की,
according to me.
बल्कि एक बार जिमी नीशम भी कर चुके हैं, जो भारत के खिलाफ नॉन
I think this the
स्ट्राइकर्स एंड
first
पर
half should be
आसान सा
minus
रनआउट मिस करते थे।
minus G. The
बाकी
second half should
रनआउट तो
be
यहाँ
like
शहजाद
positive G.
जकाती ने भी मिस किया
That's
था,
what
ये
should
कहें तो
be going
थोक
on
के
here.
भाव में रनआउट्स
And
मिस कर
that is
दिए
the
थे।
projectile
मौका
motion
था
where you're
सीएसके
like
और दिल्ली
literally
चार्जर्स के
putting
एक
up the
मैच का,
projectile, it
जहां
goes
शहजाद
down
जकाती
like
की एक बॉल पर
and comes
लोरेंस
back
स्मिथ
here
ने
down.
कवर्स की ओर एक शॉट
Jeez.
खेला और क्विक
Now,
सिंगल के लिए
let's
भागने
go
लगे।
through the other one.
कवर्स पर खड़ा
Alright.
फील्डर फंबल कर
Here,
देता है
this is
और
the
दोनों बल्लेबाज
parabolic path
आसानी से
equation that we're
सिक्के ले
gonna
लेते हैं,
follow up.
पर
This
जैसे
is the
ही फील्डर
parabolic path
बॉलर की ओर
equation,
थ्रो फेंकता
which
है,
is actually
तो
very
शहजाद
interesting to
जकाती
know.
उसे
It is
कनेक्ट नहीं कर
like
पाते,
quadratic
और लोरेंस
equation
स्मिथ
as
मौका
x square,
देखकर
and this is the
दूसरे
coefficient of
रन के
x
लिए
square,
भागने लगते
and
हैं।
this is the
हालांकि
coefficient of
दूसरा
x,
बैट्समैन
with
रन
this
लेने के लिए
basically
मना
showing the
कर देता
arrangement
है,
of the
और
terms
स्मिथ
here.
आधी
This is
पिच
the
पर लग
parabolic
जाते
path
हैं।
equation.
अब सीएसके के
Now,
लिए ये रनआउट का
this is not it.
आसान सा मौका था, लेकिन जकाती एक
We
बार
will
फिर
have
बॉल को
another
नहीं
one
पकड़
going on.
पाते और बेल्स हाथ से ही गिरा
You look
देते हैं।
this. Look
ये
at
देखकर
this.
स्मिथ वापस क्रीज की ओर आने लगते हैं।
Okay.
आनंद फानन में जकाती
The path
बॉल
of the
की ओर
projectile is
भागकर कलेक्ट
parabola.
करते हैं, और स्टंप्स के पास
Expression
आए
for
दूसरे फील्डर
maximum
की ओर
height.
बॉल
It is
फेंकते
a
हैं,
maximum
लेकिन भाई
vertical
वो
length. So
फील्डर
we're
भी
gonna
बॉल मिस कर
derive
देता है।
this with the help
सच
of
बोल
this
रहा हूँ,
kinematic
विकेट के
equation.
पीछे से एमएस
We
धोनी
take
का
this and we
रन
convert this into
जकाती को
2g.
स्टंप्स
H
उखाड़ कर
is
मारने का
equal
तो
to,
जरूर
this
किया
will
होगा।
become 0 because there is no final velocity for y, but there is an initial velocity. So 0 minus u square sine square theta, and this is actually gonna be plus here, okay?
और जब आपका स्टंप पहले से ही उखाड़ चुका हो, तो
Because
शॉट
it's
मारने का
gonna get
कोई
cut off
फायदा
with
भी
this
नहीं
both
होता।
of them.
ये हमें देखने
Then
को
h
मिला
is equal to u
बांग्लादेश
square
और
sine
वेस्ट
square
इंडीज
theta
के
by
एक मैच
2g.
में, जहां रोमारियो
All
शेफर्ड
right.
की शॉट बॉल पर तस्किन अहमद क्रीज में कुछ ज्यादा ही डीप चले जाते हैं और उनका पैर स्टंप्स पर लग जाता है। यानी वो ऑलरेडी हिट विकेट हो चुके थे, लेकिन इसके बाद वो बॉल को सिक्स पर भेज देते हैं। दर्शकों और कमेंटेटर्स को तो लगता है जैसे उनके हीरो तस्किन ने 6 मारा है, लेकिन असल मजा तो तब आता है जब कैमरा घुमाया जाता है और सबको पता चलता है कि तस्किन पहले ही आउट हो चुके हैं।
देख लेगा देख लेगा
Malaria India only.
Steps on the stumps
क्या
and then absolutely nails it for six.
और
Yes, smashes it out of the middle of the bat. वैसे आउट होने का ऐसा ही शौक एक बार क्लियर
here we
पोलार्ड
go.
के सिर भी चढ़ा था
Now
क्योंकि इस
your
मामले में
y
वो
will be written as a y
अपनी
article
जिंदगी तक लड़ रहे
component,
थे
use sine theta,
मौका था
vy as 0 and ay as minus g and t as 2t. By using the equation vy is equal to uy plus ayt, we will write this as u sine theta minus gt and this is 0. Overall, we'll get gt is equal to u sine theta here. Now g to t, so when I take this down here, should become time period of 2 sine theta, uh, 2 sine theta by g. Alright, right. So, yep,
क्रिकेट के इस मैच का और
horizontal
टेक्सास सुपर
range.
किंग्स के खिलाफ एमआई
This
न्यूयॉर्क के
is
क्लियर पोलार्ड लेग साइड की तरफ एक हल्का
r
सा टैप
with the
करके
horizontal
सिंगल लेने
velocity.
भाग पड़ते हैं
And
पर
in the time
पोलार्ड
of
को
flight,
यकीन
you are
था कि
taking
भाई
this
यहाँ
you
वो आराम
horizontal
से सिंगल
component
ले लेंगे
in the time period
इसीलिए
that
वो
is
वॉक
2
करते
sine theta
हुए
and u
भाग
cos
रहे थे
theta. When you
लेकिन
write this
तभी
down, you
सुपर
get u
किंग्स का
squares of 2
बॉलर
sine theta cos
तेजी से
theta by g.
फ्लिक
Now, this
लगाते
is
हुए
a
बॉल को पकड़ता
trigonometric
है
identity,
और नॉन
and you
स्ट्राइकर
get this
जेंटली और
converted
एक
as u
जबरदस्त
squares sine
डायरेक्ट
2
थ्रो
theta
मारता
by
है
g,
जिसके बाद
and
पोलार्ड के
overall, this
पास
is your
क्रीज तक
formula.
पहुंचने का कोई
Now,
मौका
let's
नहीं
try to
बचता
find out the
बाउंड्री पे
velocity.
भी
How do we
लौटना पड़ जाता है
exactly find out the velocity of the projectile? Let's say I take the point here pxy. It has a certain velocity. I kind of vector resolve this. I get vx vector and vy vector.
इतनी भी जल्दी
Once
नहीं
this
होनी
goes into
चाहिए
the
कि आप
horizontal
अपना ही
projectile
मौसम
here,
गवा बैठो
here we
और
can
दुनिया
see that
आपको
there is a
जोकर से
motion
जोकर
taking
बोलना
place,
शुरू कर दे
and
कुछ
that's
ऐसा ही
how
हुआ साउथ
overall
अफ्रीका
the
और
motion
ऑस्ट्रेलिया के
is.
इस टेस्ट मैच में
Now, here as you
जहां
can
रंगी
see,
नेगी की बॉल पर स्टीव स्मिथ ऑफ साइड की ओर एक
look at this
डिफेंसिव
one.
शॉट खेलते हैं जो उनके बैट के बीच से आया था और पैड से तो कोसों दूर था
So yeah.
पर न जाने क्यों लंगी निगेटी हल्की सी अपील करते हैं जिसे अंपायर नकार देते
Now
हैं
this is how
क्योंकि
it's
यहां
going to
दूर
take
दूर
place,
तक विकेट की
taking
तो
the
कोई
value of
चांस ही
vx
नहीं
and
थी
taking the
लेकिन
value of vy.
साउथ अफ्रीकन
Now by
कैप्टन
this we
डेम्बा
will have the
बटुआ
vector
इस अपील को
resolution. This is
बहुत
the
सीरियसली ले लेते
vector
हैं
of addition, I
और वो
guess. That's
तुरंत
what you can
क्लियरेंस
say.
ले लेते हैं
The
अब
addition of
पहले
these
तो
two vectors,
कमेंटेटर्स को
and then
लगता है
overall
कि
we have u
शायद
square
मैदान
plus cos
पर ऐसा
theta.
कुछ हुआ है जो उन्होंने
And
मिस
then,
कर
then, then
दिया
what else? Here we
और
have u
इसलिए
square
सभी
plus gt
क्यूरियस
square,
होकर
t
रिप्ले
square
का
plus
इंतजार
c2
करने लगते
u
हैं
gt sine
लेकिन
theta.
रिप्ले देखने के बाद किसी की हंसी नहीं रुकती क्योंकि यहां साउथ अफ्रीका ने शायद क्रिकेट हिस्ट्री का सबसे घटिया डीआरएस लिया था
Yeah.
बाकी घटिया से याद आया कि पाकिस्तानी टीम का फनी फील्डिंग मोमेंट देखे बिना तो ये वीडियो जस्टिफाई ही नहीं हो
Yes,
सकता
okay. So the
ऑस्ट्रेलिया
horizontal
के खिलाफ
projectile.
एक मैच में
Suppose I
बल्लेबाज
take an
हैरिस
object.
रऊफ की बॉल
You know
को
what? Let's do it
बाउंड्री की ओर
practical.
मारता है
Let's do it
जिसे रोकने
practical.
के लिए एक
I
तरफ तो
have
मोहम्मद
a
वसीम आ रहे
body,
होते हैं
suppose. Okay, I have an object, and I take this object. I take this object, I throw it normally. You see that this object I threw is going through horizontal projectile. Let's do it again. I throw it this side. Okay? I will throw it in this way and you will find it out. Hey, Hyder12312, how are you doing today? This is projectile motion. What I just did is that I took the object, and once I took the object, I launched it up, and therefore this projectile motion is taking place here. That's what exactly we're gonna do. We're gonna understand the projectile motion here. This is what I'm talking about. The horizontal projectile motion. I threw that thingy, and once that was launched, it actually went down, and that's how we're understanding. This is the initial velocity u having being placed. You know what? Let's do it again. Let's do it again, and I will teach you that. So we have this thingy here. You can look at it, right? And now I threw this, and blam. That is projectile motion right there. I just threw that up and it went back down, showing the projectile, and that is in covering a parabolic path. This parabolic path you see is done by this object, And let's keep that back. Okay, now let's go.
लेकिन जब वो दूसरे
And
रन के लिए
we
भागता
are
है
now
तो बीच
seeing
पिच पर
this
टकराकर
parabolic, but
गिर
there
जाते हैं।
is a
फिगर में दोनों
projectile.
के हाथ में बॉल आती है,
Very fun.
लेकिन वो बॉल अपनी साइड के स्टंप्स पर ना
If you look at
मारकर
this
बॉलर
is
की
how we
ओर
can find the
फेंकते
time
हैं।
period.
पर
It's
इससे
pretty
पहले
much
कि बॉलर
simple, and this
स्टंप्स
is
को
the
मिसयूज
normal
कर पाता,
equation.
बैट्समैन
Feels
क्रीज
like
में
you're
पहुंच
solving a
जाता है।
standard equation
फिर
here.
दूसरा फील्डर बॉल को उठाकर विकेट कीपर साइड स्टंप्स पर निशाना लगाता है, लेकिन उसका
Alright,
निशाना चूक जाता है और बॉल
checking
बाउंड्री पर चली
this.
जाती है।
That is t is equal to root 2 h by g. H is equal to gp squared by 2. And then well, r is equal to u into root 2 h by g. What is the velocity again? The velocity should be about like u squared plus g squared t squared under root. And
तो दोस्तों
look
ये
at
थे
the
क्रिकेट के कुछ ऐसे
resolution.
फैक्ट
That's how
आज
you're
के
getting
आपने
it,
अपना
and
दिमाग जैसे
here
गर्म
how
शॉट
you
कराए
find. That's how you find the
थे।
angle.
अब अगर आपको ऐसे मोमेंट्स
And
देखने में मजा
now
आया
we
तो
are
कमाल है।
starting our
ये तो सिर्फ
circular
क्रिकेट ही
motion.
नहीं था,
Yes, we're
हमारी
gonna do
पूरी
circular
लाइफ
motion,
मूवमेंट्स इन
and
क्रिकेट
we're gonna
सीरीज में
understand
ऐसे
this. Let's
और
do
भी
it a bit
पागलपन भरे
practical.
सीन्स हैं जहां खिलाड़ियों
Let's
की
find
हर
something which is
हरकत पर
capable
आपको
of
हंसी भी
being this
आएगी
kind of
और
circular
शर्म भी।
motion. So I take this kind of supposed thingy. Oh shoot! Oh, wait a minute. Okay, by taking this, I rotate this thingy. By rotating, I'm actually creating a circular motion. Um, let's show that up here. This is your circular motion. The uniform circular motion shows that the velocity is equal. But then, since velocity is also changing at the same time, what is going on exactly here is that the velocity is having its magnitude equal, but the direction is continuously changing. Let's understand this normally, okay? I took the headphones, I rotated normally, okay? Let's rotate this nicely and we'll get the idea here. And you can see that it is a uniform circular motion. By this uniform circular motion, you can look at the idea of what is going on. It is actually rotating, it is showing the point object being at this circular path. And yeah, but looking at this, if we release that object, and if there was if it went beyond the tension, it would have been this kind of motion here, it would have been tangential to that direction. We have to now study angular velocity, then we have to check angular acceleration, time period, frequency, and what else. I think yeah, that's it, but then we have to go through the formulas. That is v is equal to r omega and a is equal to r alpha. Here this is your frequency and the difference and the angular velocity and frequency formula, or angular frequency and frequency formula, showing this overall thing. And you can convert this frequency in terms of time period, that is w is omega is equal to 2 pi by t. That's how you're doing it, because you know mu is equal to 1 by t here. That's why. Then omega is equal to 2 pi mu is equal to 2 pi by t. By understanding this, now let's do something very complex. You see this something very interesting derivation. This is known as velocity triangle. I like this derivation because it's very conceptual. You're taking a point here, you're showing that point, and the velocity is in this direction. Let's take another point, and the velocity is again in this direction. Now I take this point, let's say I take this direction here and keep it here, and I take this direction again and I keep it here. Now the resultant of these two sides you see is basically v2 vector, and we can actually do this by applying the triangle law of vector addition. AB vector plus BC vector is equal to AC vector. That is BC vector is equal to v2 minus v1 vector. That is BC vector is equal to delta v vector. That is change in the vector quantity. Now if I take only the magnitude, I will have to get only v value, and we'll put this up in this one and we'll understand this side by side. Now delta theta is you can be written as L by R or BC by R, and this is a velocity triangle, that we are saying that L is equal to the length of the arc is almost equal to delta V, because this is very negligible and small. That's why So that's where we're considering the L as delta V and R as a velocity triangle, because we can look at this and you get the idea that it is equal to this velocity here. Now this one world gives you the value as delta theta is equal to delta v by v. Now we'll divide this delta theta with delta t and even delta v by delta t. By doing this, I separated 1 by v by 1 delta v, and I get 1 by v into delta v by delta t, and here that's delta t by delta t. Now delta theta, this theta you see is an angular displacement or angle, and dividing it with by time I will get angular velocity, and this angular velocity is equal to the reciprocal of the velocity, linear velocity, and delta v by delta t is a formula for acceleration, and this is not any ordinary acceleration, this is centripetal acceleration. This centripetal acceleration means that it is the acceleration influenced by the centripetal force, that is omega here, and here I take this velocity and I transpose it here, so I get angular velocity into linear speed is equal to centripetal acceleration. Now taking this and converting this v into omega r, I get omega into r into centripetal acceleration, that is r omega square, and I take this and convert into v square by r, that is centripetal acceleration is equal to omega r. Now I get overall as a centripetal acceleration as v squared by r. Now force, the formula of force, it's simple, mass into centripetal acceleration, and that's how we get m into v squared by r, and that is the overall formula we got. Now let's look at some basic ones. We can complete the physics chapter, it's easy. Motion in plane is not hard, guys, we can do this. Now look at the relation between the linear velocity and angular velocity. Let's find that out. Okay, this is interesting, it's very easy, you don't need to worry about this. So first of all, let's understand this one by one. Linear velocity of a body moving in a circular path is given by v is equal to r omega, and that is basically dv by dt, and that is dr omega by dt. And by taking omega here and r separation, that is dv by dt, this is r d omega by dt. Now we're taking derivative on both sides, that's how we're solving this out, and that is dt by divided on both the sides, and we get it as a, and yeah, the acceleration alpha, and alpha, that is a is equal to r alpha. That is all. Yes, this is easy, this was fine, but what about how do you get the angular velocity and linear velocity? How are you exactly doing it? How are you actually having this kind of formula being done? And we will find that out. Wait. um okay, let's look at this one. Look at this. This is your omega is equal to delta theta by delta t, normal formula, and this is v is equal to delta l by delta t. Fine, that is very fine, not hard at all. Now delta theta can be represented as delta l by r, and we know that delta l and delta t will give us v, and here that's how it's being done. Delta theta by delta t, we're going to divide it by delta t on both the sides, and we'll get delta theta by delta t, and this will as v, that is v is equal to r omega. This is v is equal to r omega, and that's how we are getting it. Now centripetal force, what is centripetal force? Easy, the force acting towards the center of a circular path along its radius. This is along its radius is called centripetal force. Suppose I'll take this headphones and I'm gonna rotate this headphones. By taking this headphones, I'm gonna rotate it. Like, look at this, okay? Look, this is what is going on. I'm gonna take this again, rotate it, and we are gonna do this nicely. So here it is. This is your centripetal force. The headphones are rotating, and by the headphones being rotation here, that is circular path is being followed here. You can look at the circular path, and that circular path you see here is basically showing us the tension of the string. You see, this is the tension. You can look at the tension, and here it is actually showing the angular velocity, angular acceleration, and many terms. And also, overall, this has been a lot of methods given here on centripetal force, as this much, and overall, yep. If important note, when a body moves on a circular path, the velocity v is along tangential direction, while centripetal acceleration is towards the center of circular path. So, what can we say? Angle between velocity and centripetal acceleration is 90 degrees. Alright, looks like our chapter has ended, and yep. What else do you want to know? This is me. Our chapter has overall ended. Physics, second chapter, motion in plane. Let's go. How are you guys doing today? This is me, Totality Higher. That was quick and that was fast. That was not at all slow. We did it. We really did it. We are gonna make that close. Phew. That was fast. Oh, yep, that was really good. Oh, yeah. We smashed it up. We did it. That was good. That was good. How are you guys doing today? That was so good, man. That was a really good experience. We literally overall completed physics, second chapter and third chapter. So and first chapter, my bad. Now there are only two chapters to revise. That is mechanical properties of solids and this laws of motion chapter. And then our physics revision second time has been done, but we gotta do numericals and why. Overall, yep. And thank you for 77 subscribers. I don't know who those two people subscribe to my channel, but I'm really happy that some people really did. We're close to 80 subscribers. We just need 3 more and we will reach 80 subs. Can we guys reach up to 80 subs? I'm really keen to reach up to that sub count. You gotta do that, guys. We gotta really have to. Okay. Oh shoot. Oh shoot. Give me my money. I'm just joking. Bro, I'm not that bad, you know? I'm not really bad at all. Ooh. Ooh. Huh? Coaster, huh? This is expired, I feel. If this is expired, I'm cooked. Let's eat expired yogurt. If this is expired. I think this is expired, yet I ate it. Yes. Ooh. Ooh. Broken. Ah, come out. This isn't coming out. Oh, shoot. Why? Oh, okay, it did. Oh.
इधर आओ जरा टेबल को
slowly आ तो मुझे बच्चा फोटो जरा करो is he going to tell all of his students
Yes, we are. We did it, guys. We really did it.
We did it, guys. We really did it.
Look at her. I'm gonna switch the camera on.
Look at her. I'm gonna switch the camera on.
Yeah. क्या हुआ पढ़ लिया हमने फिजिक्स सिर्फ 2 चैप्टर्स बचे फिजिक्स के Yo! How are you doing? How are you doing? This looks very weird, actually having a person watching me like this. I mean, and then I'm not doing anything for him. The content looks very weird and bad. This content is super bad.
This content is just super bad, girl.
Stop!
Stop.
Come on, buddy. Hit it. Go. Go. It's gone. What a guy. What a guy. Look at you. This is going to be fun. We're now getting into the batter. Kieran, welcome. Rash?
Yeah.
This is the first time you're bowling to somebody who should be able to bat. It's easy mode. Leg spin. It's slow. It's up. It's off.
Ouch.
It's 6. He can play.
Don't do me.
Oh.
Oh.
He just walk off. Does that annoy you? Look at him walk off.
See the next one.
Oh. Wow.
Right, another batter. Look at him.
I like his confidence, but he's nervous.
When batters walk out to bat, do you watch them walk out to the middle?
Watch them.
You just, is it eye
Yeah,
contact?
I do watch them when they're walking, and I do watch them when they take the stance, and they
Gotta go now. This is very weird. Bye. This is